Today, I'm going to answer the biggest question when we do u substitutions for integrals. That is, how do we choose the u? In this tutorial, I'll give you a total of 20 examples, and the last 8 questions are going to be trickier, but don't worry, I will make sure you guys understand. I have a file right here, you guys can go download it, the link is in the description. And for this right here, we'll just be focusing on getting the u and also the du, and you guys will finish the integrals on your own. And this right here is extremely important for your calculus classes. Especially if you are starting Calc 2, make sure you master this really well. Okay, starting with number 1. We have the integral of sine to the third power x cosine x dx. Firstly though, we have cosine x dx. So we have to think about it. The derivative of what function will give you cosine x? The answer for that is sine x. And we do have sine x right here. But be careful, this is sine to the third power. So what's happening is that this is sine x in the parentheses and then raised to the third power. So ideally speaking, I just want the sine x function. And in fact, when you do u sub, try the inner function first. The reason I say try is because once you get to Calc 2, sometimes you have to use different techniques. U sub is not going to be enough. But if you try the inner function, let u equal sine x. And then take the derivative, just go ahead and write down du for the derivative of this. And then the derivative of sine x is cosine x. And then put down a dx right here. Make sure you have the du and also the dx. Now have a look. We have cosine x dx, which is this part, that will give us the du, so we will have the integral of u to the third power du. And we can finish that in the u world by doing the reverse power rule. I'm going to let you guys finish that. Now, moving on to number 2. Integral of 1 over 3x to the first power plus 5 dx. On the bottom here, we just have a linear function, meaning we just have x to the first power. In that case, you want to pick the whole thing to be your u, because we can integrate 1 over u. We'll just get ln absolute value of u. So go ahead and let u equal 3x plus 5. And then again, do the derivative. Du is, the derivative of 3x is 3. And then multiply with the dx. The derivative of 5 doesn't matter, it's just 0. Now we have this extract number 3, right? My recommendation is that go ahead and divide the 3 to both sides, and then we get dx is equal to du over 3. After we divide both sides by 3, we can isolate the dx, and then we can put this right here, and then we will be integrating 1 over u, and then du over 3. And again, go ahead and finish that, and try it, okay? Now, number 3, we have the integral of cosine of ln x over x. Again, try the inner function first. This time we are looking at the ln x. And the reason that we really want to do the inner function is because when we do u sub, it's kind of like the reverse chain rule. We have to do the chain rule for the inner function. So when we do the u sub, try the inner function. And again for this one, if you put u equal ln x, du, the derivative is 1 over x for the ln x. And as you can see, we have dx over x. These two together will give us the du. Number 4, integral of e to the square root of x over square root of x. Now, what function do we choose and why? Well, in this case that I'm actually going to choose the inner function right here, the square root of x. The reason I'm picking u to be square root of x, it's because that is the inner function inside of my exponential function. Try it, and if you take the derivative, du is equal to, and you should remember the derivative of square root of x. It happens a lot, so it's worthwhile to remember it. You get 1 over 2, square root of x, and then put on the dx. Now as you can see, you have the square root of x, and then that. They can cancel, but we do have an extra factor too. And right here, what you can do is you can multiply both sides by this. So dx equals 2 square root of x du. Once you put this for dx, this square root of x and that square root of x will cancel. Okay, and if you haven't remembered the derivative of square root of x, write this as x to the 1/2 power, bring the power to the front, and then minus 1. That's how we got the 1/2 x to the negative 1/2 power equals the square root of x on the bottom. So far so good? Now let's go ahead and continue. Now number 5, integral of tangent to the 4th power of x times secant square x. Now this looks like we have two choices, because this means we have tangent x to the 4th power, and then we also have secant x to the 2nd power. So which inner function do we choose? Well, this is the time that we have to know our derivatives really well. What is the derivative of secant x? The answer to that is secant x times tangent x. Now what's the derivative of tangent x? Secant square x. And we have it right here. So tangent x is the way to go. We will look at this as the integral of tangent x to the 4th power, and then this, just keep it. Have a look, here is the inner function that we want. U is equal to tangent x, and then differentiate that. We get secant square x dx. Aha! That is going to be the du. Very nice. For the next one, integral of secant of 2x times tangent of 2x. What do we do? The inner function is actually the 2x. It happens twice, but it's okay. Let u equal 2x. du is equal to 2 dx. And I don't have a 2, so perhaps I can just divide both sides by 2. And if you want to divide the secant square x to both sides, isolate the dx, that's fine too, and just see the cancellation. But when you see the exact same thing, you can just replace it. When you don't see the exact same thing, isolate the dx, replace this right here, so you have that extra factor of 1/2. And then you'll just be integrating secant u tangent u. And you have to ask yourself, the derivative of what function gives you secant u tangent u? The answer for that is secant, right? So the integral of this, you are going to get secant of 2u. At the end, don't forget the 1/2. And then just go ahead and try it, write it out, and let me know what the answer is. Number 7, integral of x times the square root of x squared plus 3. What's the inner function? That is this right here, right? X squared plus 3. So go ahead, let u equal x squared. And you might be wondering, why do I put a plus 3 or no? Well, if you have du right here, the derivative is 2x dx, yes. If I put the plus 3 right here, we have the same derivative, right? In that case, go ahead and just put the plus 3 right here as well, so because it does not affect the derivative. And you have this x right here. Divide the 2x to both sides. You will see this x and that x will cancel. That would be very nice. Number 8, we have inverse tangent of x over 1 plus x squared. This time, do I choose the u from the bottom or what? Well, again, we have to know our derivatives really well. If you let u equal this, the derivative of this is just 2x. Well, on the top we have inverse tangent. That's going to be pretty horrible. But if you let u equal the top right here, inverse tangent of x, you get du is equal to 1 over 1 plus x squared dx. We see the dx and also the 1 plus x squared on the bottom. So this thing right here together is just the du. So we will be integrating u du. Yeah. So this right here is the correct substitution. Number 9. By the way, let me know how you are doing right now. Okay, number 9. Integral of cosine x over 1 plus sine square x. So what's the inner function? Well, the key right here is that we have the square for the sine, right? So we will look at this as the integral of cosine x over 1 plus parentheses sine x to the 2nd power dx. This right here will be more clear. And you will see that this is the inner function. And if we put u equal sine x, du is very nicely equal to cosine x dx. And we have that exact same thing on the top. So this is the way to go. Number 10, integral of e to the x over 1 plus e to the x to the third power dx. The inner function inside here, right? Take the plus 1 as well. Put u equal 1 plus e to the x. Differentiate that. The derivative of 1 doesn't matter. The derivative of e to the x is just e to the x. And we have that on the top. Very nice. Now, number 11 is trickier. We have the integral of 1 over square root of 1 minus x squared times inverse sine of x. What do we put? Well, this right here is kind of like the inner function, right? 1 minus x squared. But if you differentiate that, you will get negative 2x. I don't have negative 2x for whatnot. There alone, I have this thing right here, right? So this right here is even worse. So this time though, it's not this thing, it's not the square root part either. Instead, it will be the inverse sine function, because when you have the u equal to sine inverse, the derivative is 1 over square root of 1 minus x squared. This is the derivative of that, and you see 1 over square root of 1 minus x squared dx. So we have the du part right here. So you have to know your derivative really, really well. Lastly, for this one, integral of secant x times tangent x over 1 plus secant x. We have secant x, tangent x. So I kind of want to have u is equal to something with secant x, right? In fact, it's the bottom right here now. I will let u equal this. So 1 plus secant x, the derivative of this, 1 doesn't matter. The derivative of this is nicely equal to secant x times tangent x. That is exactly what we have on the top. Yay. All right, we are going to get into the trickier examples, so get ready. Here we go. Number 13, we have the integral of x over 1 plus x to the fourth power. What if we let u equal 1 plus x to the fourth power? This will give us du equals 4x to the third power. Unfortunately, I don't think this is going to work, because we have x to the third power, but this is only x to the first power. I cannot cancel the x right away, and I cannot really solve for x right here. I could, but you get like the fourth root. I think that would be horrible. So unfortunately, this is not correct. Sometimes your first step is not the correct step, and it's okay. We just have to keep trying. Now, here's the deal. On the top, we have x to the first power. Ask yourself, the derivative of what function will give you x to the first power? And the answer for that is something with x squared, right? X squared, differentiate that, we get 2x. The constant multiple of the 2 doesn't really matter. So now, if you look at this integral, do we see x squared somewhere? No, but also a yes. No, because you really don't see the x to the second power. But yes, we have x to the fourth power. We are going to rewrite this as x over 1 plus x squared and then squared. And now we are in business, because now we can let this equal our u, and then du is equal to 2x dx. Have a look, we have x to the first power, and that will be able to cancel with this x. I know we have a 2, but doesn't matter. Constant multiples, we can put it on the outside of the integrals. And right here, maybe we can isolate the dx by dividing 2x to both sides, like so. And this x and that x will cancel. Make sure you still have that 1/2. Number 14. This is similar to number 1, except for that we don't have the cosine x anymore. So if you let u equal sine x, well, du is equal to cosine x, but I don't have cosine to help us out. So once again, this is not really going to work. So what do? Well, for this case here, notice that we have sine to the third power. We can actually take out one of the sine x. Have a look. So this is sine square x times one more sine x. So this is now going to be similar to example number 1, where we have a sine x factor here. But you have to think about derivative of what function will give you sine x. The answer is cosine x. Even though the derivative of cosine x is negative sine x, but the negative, again, doesn't matter. It's just a negative one constant multiple. I don't see no cosine x here, so what do we do? The key right here is sine square x. That should be familiar. The Pythagorean identity, we can change that to 1 minus cosine square. So that's the key. This right here, rewrite that as 1 minus cosine square. I'm just going to put it down like so. That it's this part, and then we have the sine x dx. And then we have that cosine x that we want. Again, it's just cosine x to the first power. U is equal to cosine x. Do not do the second power, because if you do, you have to use the power rule and also the chain rule. Let me show you real quick. If u is equal to cosine square x, you can put a square on this right here. Du will be, bring the 2 to the front, minus 1. So 2, keep the inside. And then you multiply by the derivative in the function, which you will have that extra sine x. Don't do that. All you want is u is equal to cosine x, so you get a much cleaner derivative, which is negative sine x dx. And then you have the sine x here, you have the negative. You can just multiply a negative and divide it by a negative, or to be consistent, you can say dx is equal to du over negative sine x. Put this here, you can cancel out the sine x. Okay, number 15. Wow. I don't think I want to let u equal the whole denominator. Like I had derivative x plus x times ln x. It's a little bit too hard. Plus, I don't have anything else that I can really work with. So what do we do? Notice here we have x, and this is x times ln x. This and that we can factor it out. So let's go ahead and do just that. And we will get 1 plus ln x. Alright, is this much better? It should, because now I can put u equal the inside. If u is equal to 1 plus ln x, du is going to be nicely 1 over x. And we have the 1 over x right here. Very nice. Now, how about this? E to the x over 1 plus e to the 2x. Right here, do not say u is equal to the bottom 1 plus e to the 2x. Because when you differentiate this, you have 1, which will give you 0, but the derivative of this is e to the 2x. Use the chain rule, multiply by the derivative of 2x, which will need a 2. Not only you cannot cancel all this, and here the problem is that on the top is e to the x. This is e to the 2x. You cannot cancel out right away, and I don't think you can simplify any further in this regard, so this is not it. So what do we do? On the top we have e to the x. Derivative of what will be e to the x? It's just e to the x. But do we see just e to the x somewhere else? Again, it's a no, but also a yes. This is kind of similar to number 13. Right here, rewrite it as e to the x over 1 plus. Instead of e to the 2x, put it as e to the x and then square. Now we are in business. Put u equal this, and then du is e to the x dx. That is going to be the du. We will be integrating 1 over 1 plus u squared in the u world, and then we can go from there. 4 more. Number 17, 1 over square root of x plus x. If we let u equal the bottom, we have 2 terms. The derivative of this is 1 over 2 square root of x. and then the derivative of that is plus 1. I don't think we have enough things to work with after that, right? So don't do that. That's not the way to go. And if you remember, you never let u equal to just x. Never. Never, never. Never just say u is equal to x. Because you will just get du is equal to dx. And guess what? You will have integral of 1 over square root of u plus u du, which is the same exactly like what you have in the beginning. You just change the variable and it doesn't make any progress. So never, never. Alright? But now what though? Maybe you want to let u equal square root of x. Yes, but before we do that, I'm actually going to factor out the square root of x. Let me show you. This is the same as integral 1 over factor out the square root of x. You get 1 plus square root of x times what will be x. The answer for that is square root of x. Have a look. This right here, the inner function that I want to make is this right here. U is equal to 1 plus square root of x. Because now you see du is equal to 1 over 2 square root of x dx. Multiply this to both sides if you like. Dx is equal to 2 square root of x du. Put this back here. This square root of x and that square root of x will cancel. And it works out much better. Yeah, go ahead and try this one right here. Now, number 18. Okay, on the top we have sine x, cosine x, and then 1 plus sine square x. So again, we can look at this as sine x to the second power, like the things that we did a few times already. But if you just said u is equal to this inner function, it's actually not enough, because du is only going to be cosine x dx. But on the top, not only we have cosine x, we also have the sine x. So this right here, unfortunately, is not enough. So what exactly do we do with this though? Well, in this case here, notice that if you differentiate this, you actually bring the 2 to the front and you have to use the chain rule. And that will produce another factor. That's the key for this one. So in this one in particular, we are going to let u equal 1 plus sine square x. So that when we differentiate it, bring the 2 to the front, keep the sine function, and then multiply by the derivative of sine, which is cosine x. Now you see both factors of the sine and cosine, and that's exactly what we have on the top. I know the 2 right here, but it doesn't matter. You can isolate the dx. Dx is equal to du over that. Once this and that cancel, you will have a 1/2 factor. You can put it on the outside of the integral, and then you can continue from there. Number 19. Integral of x times the square root of x plus 3. Earlier, there was a question that we had square root of x squared plus 3. We let u equal the inside function and it works now nicely. But in this case, we only have x to the first power. What do we do? In fact, we can still let u equal the inside function. U will be still just this. And then du will be dx. But the beauty of doing this right here is that you will see, I know we still have the x right here. That's bad, because x is not allowed in the u world. The rest is square root of u. Dx is the same as du. So what do we do with this x? The key for this one right here is that after the u-substitution, even though it does not cancel out the x right away, but we can look back to here, and let's just kind of work with this equation. Subtract 3 to both sides, we get x is equal to u minus 3. So we can replace this x with u minus 3. And remember, when we have the square root, that's the same as the 1/2 function. 1/2 power, right? And then you can distribute, and then you can use the reverse power rule after you get a new power, and then just integrate it from there. Now for number 20, tangent x times ln of cosine x. Here we have cosine x inside. Let's just go ahead and try that. Let u equal cosine x. du is negative sine x dx. Okay, but I don't really see the sine x from here. Well, not yet, because tangent x is the same as what? Sine x over cosine x. Pretty nice, huh? And then we have ln. Cosine x is the u. And then dx, well, I'm actually going to isolate the dx from here. And to do so, I will just divide this to both sides. So du dx, I will divide both sides by negative sine x. So dx is the same as du over negative sine x. So I will replace this right here. And now have a look. Sine x cancel. Well, we do have this cosine x, but don't worry, because that is the same as u. So I can replace this with u. Now we have this negative, so make sure you put it to the very outside. And then we have the integral. Here we have ln u over u. And then we are in the u world. But now let's think about it. The derivative what function gives us this right away? Well, if you can write down the answer, good. But this is not from the derivative table. So what do? In fact, we are going to do another substitution. And for the substitution, you can pick any letter that you want, as long as it's not x, it's not u, because we use them already. Let's do t. But what do we do though? The bottom? No, you never just let t equal another variable. No, don't do that. It has to be something else. Notice that I put down a parenthesis of u inside of the ln. But again, don't just do the t is equal to u. Not that. Here, our variable is going to be this, ln u. When you have one thing instead of the natural log, you really don't need the parentheses. But anyways, if you have this right here, dt will be, take the derivative of this, that will be 1 over u du. So you will have to take this integral to the t world again, another world, and then you'll be able to integrate that in the t world, and then make sure you finish that and you go back to the u world and you go back to the x world. I know this is the harder part, right? Here is the deal. In fact, if you begin this integral with u equal this, you can just finish this integral with one substitution. You can go ahead and try that. I'm going to leave that to you. Hopefully this right here helps. Integrations, they are not easy, I will tell you. Once you get to Tail 2, you have a lot of techniques to learn. I have tons of integral tutorials for you guys. Make sure you guys check them out, and best of luck for your calculus classes.